Hey, folks, we'll get started in just a minute as soon as I get everything set up to share. With apologies if the snoring in the background bothers you, my dog has decided he wants to sleep in the room with me today, and he's snoring heavily, but that's okay. He's adorable. It's worth it. All right. My clock has 4 o'clock, so let's go ahead and get this started. I will put out this message more formally later today, but you can have until next Wednesday to finish the lab that was assigned yesterday. I think it was Lab 7. The lab that was assigned yesterday obviously has dictionaries. I thank Mariah and Kevin. They showed me what they were going to work through. I think they did a pretty good job covering the topic, but since our lecture is not until next Monday, it's kind of unfair to ask you to finish that lab before that. So you will have until next Wednesday, the 31st of March, to finish Lab 7. Now, again, we're starting to load you up rather heavily with work. You know, you get the homework assignment. You've got the first project coming out this Friday, which will take 2 weeks. So, you know, if you really want to hold off until after the dictionary lecture next Monday rather, that's fine. I understand that completely. If you want to go ahead and get it done early, you can go ahead and knock that out. So it's up to you. We're not going to force you to try to wing it on your own before the lecture. As I said, I'll post that on Blackboard when I get a chance. All right, so today's topic, we're going to do some more with file input and output, but today's topic is largely going to involve multidimensional lists. Two-dimensional lists, you can do three-dimensional lists, you can do as many dimensions as you want. We're going to focus mostly on two-dimensional lists because that's what people mostly deal with in real life in Python. A two-dimensional list is just a list whose individual elements are themselves lists. So, you know, we've seen how to do a list of integers. Okay, it's straightforward. We've seen how to do a list of floats. That's straightforward. We've seen how to do a list of strings. Okay, the Detroit Tigers pitching rotation from about 4 years ago. We've seen how to do a list of Booleans, and we've seen how to do a list of things who are all different mixtures of elements. That's fine. But now we want to extend that, and we want to build a list whose individual elements are themselves lists. This list of lists is itself a two-dimensional list. Now, the data set we're going to use in our examples is this one. Okay, so the last IAAF is the International Amateur Athletics Federation. It's the governing body for world track and field. So all the Olympic runners and high jumpers, etc., compete under this, under IAAF. The last time they had a world championships, this was the medal table, the table that shows which country won how many gold medals. This is supposed to be gold. How many silver medals. This is supposed to be silver. How many bronze medals in total. And I just copied the table for the top 7 countries. So we've got a line that's a header line that tells what each column is. And then I've got the 7 rows that are actually the data I wanted. This actually goes on to, I think there were 20 different countries that won at least one bronze medal, but that doesn't fit on a slide. So we just take the top 7. And you can see that the United States had 14 golds, 11 silvers, and 4 bronzes for 29 total medals. What we want to do is capture this in Python. And there are a number of ways to do it. First off, we're just going to get used to the syntax of 2D lists before we do what would be common and read it in from a file. Okay, so I want to create a two-dimensional list. I want to create a Python list of lists that incorporates all the data in this table so that I can do some data analysis. Okay, what I'm going to do is I'm going to create in 2D lists. We use the terms rows and columns because conceptually, pardon me, just a second, go back. Conceptually, we're going to have this row, this data incorporated as a row, this data as a row, this data as a row, and the things that are in corresponding places in each row are the columns. So each row we're going to create now, for now, we're going to add it later, but we're going to leave out the country name. We're just going to deal with integers. We're going to include the rank, the number of gold medals won, the number of silver medals won, the number of bronze medals won, and the number of total medals. We will later on add the country name as a list element, but we're going to leave it out for now. We just want to do the integers. So what we're going to do is we're going to create a two-dimensional list. Each row of our 2D list is one row from our data table that has these values. Okay, and so it looks like this in Python. Okay, we create a variable, just a regular Python variable following the same variable rules, snake case, medal underscore table equals. Now, syntax, this can get you, this can cause a lot of errors, and I probably, as we go through the coding for today, will make a number of errors that we'll have to correct, but it's just practice, is getting used to the syntax. When we create a 2D list like this, with data in it, we have an outer square bracket. That's the beginning outer square bracket. That's the ending outer square bracket. And then we have each element in here. Now you can see each element is itself a list. First place country, 14 golds, 11 silvers, 4 bronzes, 29 totals. That is a list, so it's in square brackets. The fact that it's in square brackets means that this is a list. List elements are separated by commas. So this list is what you've seen before, and then a comma, the next list element. Then 2, 5, 2, 4, 11 is the second place country. Then 3, 3, 5, 4, 12. Third place, 3 golds, 5 silvers, 4 bronzes for a total of 12. Okay. In most international standings, they rank countries by the total number of golds won, not the total number of medals won, which is why this is the third place country is who? Kenya? Yeah, Kenya is second, Jamaica is third. This, Kenya is ahead of Jamaica, even though Kenya won fewer medals because Kenya won more golds. That's why they do this table this way. That's fine. We'll understand that later on. So anyway, this is how you declare a list of lists, a 2D list, when you're assigning the values. Okay, so I'm going to go ahead and copy that to PyCharm, just because if I typed it again, I would be guaranteed to be wrong. And so there is my 2D list. Medal table has all these values. Okay, and we can see they're all integers, and we have to know what they mean. Okay. Now, what we want to do is we want to do some processing. So we'll go back to the slides to make sure we do this. In this case, every row has the same number of elements and every element's the same type, but that is not required. And we'll see this in a minute, but Python says rows can be different length and they can have different types of elements, and then you have to make sense of them. Okay. If we wanted to add Kenya for second place, since I forgot whether that was Kenya or Jamaica, we could do that. It would be legal, but you get really bad, you really get into some coding problems you'd have to work around. So I want to make sure what I've got in the title. Here we go. Now let's go back to PyCharm. Okay, now I know what I'm doing. Okay. Now what I want to do is print out this 2D list. That's fairly simple. Print, it helps if you do spell it right, medal table. Now I'll run this code since there's nothing else there I don't want run. And we can see that this is what it looks like. Now, Python, by its nature, does not print things in pretty format. You have to work at that. We covered it a little bit. But if you figure it out, you can see that this is the first element in metal table. This is the second element in metal table. This is the third element. Okay. Now, what we want to do is we want to print out the first row. Not column, row. And that's important. That's the United States results, because U.S. finished first. Okay. The way I do that is I print metal table sub-0. Okay. If I print metal table sub-0, hang on a second, I'm going to comment this former print statement out so I don't get extra stuff there. Now I'm going to run my program. And now we can see when I printed row 0, it gave me the first list. It gave me the first element of the 2D list. Important point. When dealing with a 2D list, row always comes first. Column comes second. Metal table sub-0, let's go to a console. And let me run this code, since I don't have this in a console yet. Metal table sub-1, remember, just like 1D lists, 2D lists always start counting at 0. The first row is always sub-0. Sub-1 is the second row. This gets me a row. What if I want to access a specific element? Row, column. Here's the syntax. Be careful with your syntax. Here is what it is. It is, in this case, our 2D list is metal table. Row 0, element 1, or column 1. It helps if I can type. Okay. So that is 14. Okay, we get the result 14. Let's go back to our data table. Row 0 is this. This first element 1 is column 0. This next element 14 is column 1. So what this syntax right here, metal table row 0, column 1, does is tells me to go into this row, go to this element, because this is element 0, and find it. It happens to be the number of gold medals the U.S. won. The syntax for a specific element is variable name, row number, column number, and that gets the specific element. Now, be careful with syntax. It is not metal table sub 0, 1. Okay, that's a very common thing to do. People try to do this because, let's face it, that's the notation you learned from algebra, right? You took algebra, you took geometry, you took other math classes, and it's a two-dimensional matrix. You learn the XY coordinate system, you learn whatever, and you just write it like this, and this tells you where in a matrix it is, And so you're used to that syntax, except that fails, okay? Because Python doesn't understand that syntax. What Python thinks is this is row 0, 1. There's no such thing as row 0, 1. Okay, row 0, 1 is not a meaningful value. It can't possibly work. So syntax, you will likely, now I mentioned to you that problem 3 in the current homework does require two-dimensional lists, so that's where you'll put this into practice. Okay, if you get errors like this one, then you probably tried to use this syntax to access an element, not this syntax. Easy enough mistake to make. I do it all the time. I almost did it here. And just go back and fix it. It's not a big deal. So what we know is if you want to access a specific element, it's row and then column in separate square brackets. If you want to access a row, just use one index in square brackets. This is what we've already done, but again, okay, if you just give one index, one subscript, one square brackets, that is by definition row. Python says this programmer wants to know what the value of this row is, this list, all the elements here. What about columns? That's harder. You can't do it in a single statement. You have to use a loop. Okay? Now, it can be a for loop, it can be a while loop, it can be, you know, a number of different things. But I want to print out the number of gold medals won by each country. I'm going to have to do it like this. For I in range, we'll get to this in a minute, length of medal table, print medal table sub I sub 1, because gold medals are 1, and equals blank space. And now I'll wrap it up by printing a new line so I don't get caught. So this is my for I loop. That prints out the number of gold medals each country won. That prints out the values of column 1. There is no other way to access a column in Python. In a two-dimensional list in Python, you can access the whole row at once when you just give one index, one subscript. You can access an individual element by giving its row and column both. The only way to access everything in a column is in a loop. Python does not make accessing columns easy. It's just the way it is. Now, let's do one thing I did in the slides. I don't want to have to put 1. Okay. I happen to know that right now in this table, column 0 is rank. So I'm going to declare a constant that says column 0 is rank. Column 1 is the number of gold medals. So I'm going to say golds is 1. The next column is the number of silver medals. So I'll say silvers equal 2. Bronzes equal 3, and total equal 4. By defining these constants, now I can make this a little bit. I want to print out the number of golds won by each country. Now, instead of 1, I'm going to say golds. Okay. Now, let me run the whole program. So I get everything in there. And now you can see that this was printed out just as we expected. That's the number of golds won by each country. And if I wanted to, I could, use a better print statement to label everything, but I'm just showing you constants. So constants become more and more important when you're dealing with two-dimensional lists because you want to know what everything is. Okay. One more small thing before we start manipulating this list. Okay. That is, what if we want to declare an empty 2D list? You would think it would be something like this, that you would use 2 square brackets to let Python know this is going to be a 2D list. But if you do that, this is what happens. This is going to run forever because it turns out that this is invalid syntax and it's expecting something else. Okay. Sorry, I keep forgetting that even though it's a Mac, it's Control-C to kill that thing, not Command-C. So I was hitting Command-C and getting nothing accomplished and wondering why. Here is what you actually use. Just a single set of square brackets. That's it. You declare an empty 2D list the same way you declare an empty one-dimensional list. You declare an empty three-dimensional list the same way. Okay? Any empty list, no matter how many dimensions it's going to have, you simply declare by assigning it to empty square brackets. That's an empty list of whatever dimension. So if you're going to start with an empty 2D list, you do it this way with just a single square bracket. Now, again, following the same rules of if you use one index and one index only, it refers to rows. We talked earlier about length. What exactly is length of metal table? And the answer is 7. If we go back here to our data, we see that we have 7 rows, 5 columns, 35 values. Well, if the length is 7, that must mean that the length is the number of rows, and that, in fact, is the way it works. Length of a 2D list equals the number of rows in the list. If you use length for a 2D list, it tells you the number of rows in the list. It tells you the number of elements in the highest degree of the list. If you want to know the length of a specific row, the number of columns, then you use the length of a row. So, for example, length of metal table sub 0 equals the number of columns. So, for example, if I come down here and I say length of metal table sub 0, that tells me 5. And indeed, in my matrix, in my 2D list, there are 5 columns. Now, you have to be careful. If not all rows have the same number of columns, this might not be meaningful. Okay. What do I mean by that? What I'm going to do is I'm going to insert a single element into my list. And specifically, since I couldn't remember if the country that finished second was Kenya or Jamaica, I'm going to put Kenya in there to make it clear to me that this is what it's going to do. So the code is going to say metal table dot insert, or metal table sub 1 dot insert 1, the string Kenya. Let's make sure this works. Okay, now let's look at what the value of metal table sub 1 is. Now you can see I have inserted the value Kenya into that row. Okay, that is how you insert an individual item. It's not metal table dot insert sub 1 parentheses 1 comma Kenya. If you try to do that, that says you can't do it. The subscript has to come after the table name to say which row. So this insert says go to this specific row and then do a regular list insert into this location in the into the 2D list. That's how you insert a single element. If you want to insert or append a whole row, that works the way you would expect. Metal table dot append, and now I'm going to append the list 8, 3, 2, 3, 4. That would be 8. Okay. That adds an entire new row to metal table. Okay. So if you want to work, again, if it's a two-dimensional list and you're in Python, rows are really easy. Python makes working with rows really easy. Working with columns is a royal pain. Okay. Let me get rid of that. That should be 7. Let's make sure that works. Okay. Let's check the value of my 2D list. Good. That's gone. I'm back to my original data set. This just added and this removed. Again, dealing with columns, is a lot different. It's a pain. Let's suppose that I actually had the country names and I had a list of them. I want to insert the country names as column 1. What I'm going to have to do is define a list of the country names. Okay, so countries equal, and this is just a one-dimensional list, United States, Kenya, Jamaica, and now I have to go back and look up who was 4, 5, 6, and 7. China, Ethiopia, Great Britain, and Germany. Okay. China, Ethiopia, GB, Germany. And make sure I got my square bracket closed. Okay. Let's make sure I didn't make any typos in there. Those are the countries I want to insert. The first thing I'm going to do is I'm going to delete the element Kenya. So medal table sub 1, where I put Kenya in there, dot remove Kenya. Okay, so now we should be set. So now to add this column, what I have to do is write a loop that inserts each country into the proper row, and it's going to be something like this. For I in length of medal table, that is for each row, what I'm going to do is medal table sub I. In row I want to insert into column 1 countries sub I. Okay, I want to run this loop, and that should insert the name of the country in the proper place. Okay, what did I do? For I in length of medal table I, insert country sub I. Let's try this again. All right, what did I do? Okay. Let's see. The problem is in my for loop right here, this is not valid. It should say for I in range of length of medal table. I turned a for I loop into a for each loop, and of course that doesn't work correctly, which is why I got the error message from this. Yeah. Now, you can see that I've inserted United States. You can see that I've inserted Kenya. You can see that I've inserted Jamaica, and so forth. Okay, so that is how you insert a column. Again, the lesson right here, the point I'm making right here, is anytime you want to deal with a column as a whole, you have to get into these loops. I could have written that as a for, as a while loop. I could have done other kinds of loops. But the only way I was going to make that work as a column is to do it in a loop. I took advantage that this tells me the number of rows. I said for each specific row, I want to insert in column 1 this value. Now, I am going to have one problem. Specifically, I defined constants. So let's go up here where I wanted to print out the number of gold medals won by each country. This code worked before. I haven't changed much. Will this code work again? And the answer is no, because it turned, well, all right. It turns out that column 1 now has the country names. Okay. Column 1 is no longer the number of gold medals each country won. Column 1 is now the country name. So what I would have to do is come up here and say, change this to 2. Inserted. I have to change to 3. Change to 4. And change to 5. Okay. So I change the constants between runs or when I add in the country names to my data. Then I have to change the value of my constant if I still want to use this. But constants are still a very valuable thing to use, so you still want to do this. Okay. Let's go back to the slides and see what we've covered that I went through there and make sure I get everything before we move on to the next thing. Okay, we create that in Python, 2D list, rows and columns. Creating it by assignment, you just assign it this way. This is the syntax. Outer square brackets here, inner square brackets here. It is good to do some kind of formatting like this. This makes it easier. This kind of formatting where I use multiple lines makes it easier for me to see when I'm looking at this list. This is a 2D list. Each element is a list of integers. Each row, these are columns. I can do that, okay? But you don't have to. Python doesn't care. It will work the same, but it's just easier to format it if you're going to do this. If you're going to create a 2D list like this, it's easier to format it this way. If you're creating an empty one, then what you want to do is, pardon me just a second. I have Discord open and the beeps from new messages being posted are driving me at the wall. Sorry. If you're going to create an empty one, an empty 2D list, you should just single pair of square brackets. Rows are outer, rows are first, columns are inner. Accessing list element. The rows come first, always. And you always start counting at 0. The first row is row 0. The first column is column 0, always. Length of the 2D list tells you how many rows. A reference to the variable with only one subscript is the row. It tells you what the row is. In this case, that's the list here. If you want to access a specific element, you give the row number followed by the column number. That gives you the specific element. Okay. And remember the syntax, these are separate square brackets. You don't use a single square bracket with 3, 2 in between because Python doesn't know what to do with that. So row in square brackets, then column gives you the specific element. Again, the general programming notion using constants is a good thing to do because it helps us keep track of what the columns are. And in the example here, these are the constants I use in the program. Rank 0, initially golds 1, silvers 2, and so on. because that makes it easy to reference. If I want to say, how many silvers did somebody win? I could say column silvers. Okay. Now, so that's all good. If you want to find out, if you want to do a little bit of math on it, how many gold medals did the top 7 countries win combined? This loop will work it. Now, just to show you, let's come over to PyCharm. Presume I haven't made any more hideous typos. Let's go to, remember, just in case I haven't executed, let's set golds equal to 2. I might not have re-executed since I changed that code, so I want to take care of that. And now we can see that indeed the top 7 countries want to combine 31 gold medals. Okay. So now that's how you would deal with a column. Again, the total number of gold medals is defined by what's in that column, so we have to use the loop to add up the total number of gold medals, and it gives me 31. Now, in this example, all rows have the same number of elements, and all the elements in each row, or the corresponding columns in each row, have the same type. In other words, the first column is rank, it's an integer. The second column now, column 1, is the country, it's a string. The next column is integers, and so on. Management, if you're going to do this kind of data manipulation, management is critical. You have to make sure that you know that the same column in every row has the same thing. Remember when I went back and initially inserted Kenya, but it was the only row that had a country name. Now, if I tried to add up everything in column 1, well, column 1, there's one row that has the string Kenya, Python's going to die. Python's going to say, you can't do that. You can't add 14 plus Kenya. It's not allowed. The language C will be quite fine with that. It'll give you a meaningless answer thinking you know what you're doing. But Python, no. So you have to manage your data structure carefully to get this to work, or you're just going to get a garbage answer or an error. And to be honest, the error is better than the garbage answer because the error you know is an error and you can fix it. The garbage answer, you might not automatically say that's the wrong answer. You might say, yeah, what the heck? I didn't think that would be it. Sure, why not? Let's go. Okay, so be careful when you're going to do this. Make sure that your rows and columns line up. They don't have to. Python is quite happy if different rows have different numbers of columns and different things in each column. Hey, Python's cool. Okay. This is just an example of what happened when I put Kenya in there. I'm not going to execute this in PyCharm. You can if you want. But had I done this code when just the Kenya line had the country in and the rest didn't, which I did a while ago, this loop would fail again because you can't add 14 plus Kenya. It doesn't work. So what's worse, when I said you might not get the right answer, is if you were looking at the same situation where this row had the different value, and then you wanted to calculate the number of silvers where the silvers are in column 2, okay, this plus this plus this plus this, and so on. Well, here's the problem. When I got to this row, this third element, column 2, column 0, column 1, column 2. Column 2, the third element, has 5. Kenya did not win 5 silver medals at that track meet. Kenya won 2 silver medals at that track meet. Kenya won 5 gold medals. However, 5 is an integer. And Python is quite happy to tell you I can add 11 plus 5 plus 5 plus 3 plus 5 plus 3 plus 3. Okay, so it's not an error. Python will add all those integers beautifully and give you an answer. It's the wrong answer. It won't fail, but it'll give you a wrong answer. And as I said, in many ways, this is worse than failing because you got to know that that's the wrong answer, or you're not going to fix it, and then you'll hand in your program with the wrong answer. And then the research publication will kick your paper back and tell you they can't publish this because, sorry, that wasn't right. It's embarrassing to submit something with a trivial error caused by a bug in your computer program. Not that I've ever done that more than like 3 or 4 times over my long career. Debug your code, check it, make sure you've got it right. It's better to crash. Okay, use some data to test it. As we said, without entering the data first, basically what you do is you declare it this way. If you want to add a row, you append. We do the append down here. Now, this is a common assignment we give people. So you might see something like this on a test. If we tell you to create a 2D table that consists of all of the perfect squares of positive integers, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. And we want the first 50 squares in 5 rows of 10 columns. This is how we'll do it. And I'll walk through in PyCharm because we've got plenty of time. I'm actually doing well. It helps if I'm in the right place. Let's write the code in the editor. Building a table. Okay. Square table. I'll come back. Remember, we're going to initialize this the same way as we others. We're going to start by saying using constants, rows are 5 and 10 columns. Now, what we're going to do is first build a row, then append that row to the table as a unit. We are not going to append one value to this table at a time. We could, but it gets really, really ugly. This is the easiest way to do it. So let's build a row. For J in columns, because we're going to have 10 entries in a row, okay, I'm going to start with I equals 1. Or I'm just going to start with row. This is going to be row I. And I'm going to start with I equals 1. So for J in columns, I need to create a one-dimensional array. An empty list. For J in columns, row dot append, and the value here is going to be I times J plus 1 squared. Okay, this will build a row. Now append the row. Okay. So let's run this code. Oops, and I need to start with this'll I need to append it. Okay. So this is not actually going to do the appending. And I knew I was leaving something off. Sorry about that. Okay, what did I do now? For J in range of columns. Not with it today. There we go. Now, what does square It's square underscore table. Yep. Table dot append row. Now let's see what square table is. We can see it has the values of 1 squared through 10 squared. The first 10 values, the first 10 perfect squares. This gives me 1 row. If I want to do that for all 5 rows, then I'm going to have to come back up and put this in another loop. And I'm going to change this and say, for I in range, so let's not make the same mistake yet again the third time. Tab, tab, tab. Now append the row. And now we will print square table. This is going to be an ugly thing to print, but we'll do this first, and I'll show you how to clean it up a little bit. After I make sure that I haven't made any typos. When I do it this way, this needs to be I plus 1. Okay, now we're back to working, sort of. Okay. If I want to print it out better and have it be more pleasing, I'll have 1 line to the thing. Now it'll be for K in range length of square table. Or I could have just said in rows, but that's fine. It'll work this way too. It's the same thing. Print square table sub K. And now we can see that I've got it. Now I've actually got a math error in here, which we'll go back and look at and see what I did wrong. Okay, yeah, num to be squared. I did a calculation. I just incremented. I didn't bother adding I and j. I just kept a separate variable altogether that squared that. Let's go back and fix that. All righty, that should do it. All righty, there we go. That's right, because this is 2,500 is 50 squared. This is 50 squared, 40 squared. That gives you the right answer. So trying to come up with a quick formula off the top of my head, live demos never work. Anyway, here's the point you should take away from this. You could have looked up the values of the squares yourselves. Here's the point to take away from it. If you want to add things to a two-dimensional list, to a two-dimensional array, you have to build the entire row because you can't add a column at a time. You can only add a row at a time. You can add an individual element, But if you added individual elements, you would have had to play around with I and J a lot more to get that to work. This is the easiest way to do it. Okay, this is just improving your output, is to have one line per, one row per line, so you don't get everything messed up. It makes it more legible. Play around. One of the homework problems, I believe it was problem 1 in homework, Hamilton gives some specific text to use to make your output look a little bit better. That's fine. It's not a huge, as I said back weeks ago, printing in a pretty format is important if you want your output to be legible, but it's not a fundamental computer science. So we kind of have a split view of it in this course. We teach it to you because you need to know it, but we don't focus on it. Adding a column I've talked about. This is the code I gave you earlier. This is how to add that column to your 2D list. It has to be done in a loop. Okay, and then this is when you add a column, you have to update your constants because otherwise you'll get a wrong answer. Now what I want to do is show how you would deal with this reading in data. So if I go to PyCharm, I've already put a couple of files out on GitHub for today. The actual coding file I'm working in right now obviously isn't there. I'll put that up at the end of class. But the data files, if you want to play with it yourself, the data files are already in GitHub. What I did is I created a text file that looks like this with the data. Okay, I have a header line that has what each column means. And because Python's not real great at letting you line things up in pretty little tables, it doesn't look really great, but you can get the idea that this is just a text file representation of that data. So the first line is a header. The second line is where we start the data. Okay, so what I want to do is I want to read in this data file and create my list that way. Here's a way to do it. Rather than reading it in all at once with a read statement, which I could do, I'm going to use read line. I'm going to read in one line at a time. Okay, with open metal quotes metal table dot text. Now I've already made sure, I hope, that I'm in the right directory, so this is not going to be a problem. As in file, we'll call it in file for now. The first thing I want to do is I want to read in the header line. Header equal in file dot read line. Okay. Let's make sure I don't have any typos and I'm in the right directory and everything else is working. Okay, and we see that what I now call header has rank, remember /t, \T is a tab, rank tab, country tab, gold tab, silver tab, bronze tab, gold, total, bit. Now, what am I going to do with this? Throw it away. The short answer is, now throw this away by ignoring it. I have the value read in. I'm just never going to read. I'm never going to do anything with it. Okay. I'm just never going to do anything with it. If I want to put it in the header for use when I'm doing something later on for output, that's fine. But I just never have to do anything with it. I just ignore it, I essentially throw it away. Now I can read in the rest of the file. And now I'll call it, let's call it metals equal in file dot read lines. Okay, now I'm going to read the rest of the table into this 2D list Okay, what did I just do? Now let's look at metals. Now I have my data one row per line. I'm sorry, it as a list of strings. Each row of my table is a separate entry in my list metals. And now to create the two-dimensional list, I just need to take this and carve that up so that each element in metals is, which is a string. Let me try to be careful with how I'm explaining this. Metals sub I is a string. I want to split it on white space. And now I got to figure out what I want to do with that. Let's just execute that command. For I in range length of metals, metals sub I dot split. Now let's look at what metals is. Okay, hang on. I didn't save it anywhere. Now we can see that I have a list with the table the way I wanted it. So how I'm going to do this is this. For I in range length of metals, each entry needs to become a row. Each entry is currently a string. It needs to become a row. I'm going to create a two-dimensional matrix called data dot append metal sub I dot split. Now let's run this and make sure I haven't messed up anything else. Okay. Now we can see I have the 2D matrix, the 2D list, just like when I typed it in. So this is an example of reading in a text file, and from that text file, I split all the data up with a combination of split statements. The read lines effectively gives me a split statement. If I had used, instead of read lines, metals equal in file dot read, and then m equals, this is going to be commented out, m equals metals dot split on a new line, achieves the same result. So if I wanted to use read instead of read lines, I would take this statement and replace it with these two statements, and it would give me the same result. So the bottom line is, I had a list of lines. Each line is a row, And then I could split each line out an individual string, because when we read in from a file, it's a string, everything's a string. We could split those strings again into our two-dimensional list, and now we're ready to go. The only thing to watch out for is, remember, because everything's a string, this number of gold medals is still a string, this number of silver medals is still a string. So what you're going to have to do is you're going to have to go through and cast these strings to integers if you want to do math on them. But we know how to do that. What I wanted to show is how to create the 2D list read in from a file. This was a text file with data just separated by tabs and on separate lines. And the other thing to pay attention to here when you're reading data files is if you have header lines and you need to throw them away, this is how you do it. You simply read in the header lines and then do nothing with it the rest of the code. Now, this is a text file which I created. There is another thing that I talked a little bit about called, this is the wrong thing, sorry, I'm going to the wrong place. I need to go to Sheets. Let's see if I manage to save this. Okay. So what I did the other day when I was preparing the lecture is I created a Google Sheet with my table on it. If you haven't used Google Sheets, it's the same thing as Excel on a Microsoft. It's the same thing as Numbers with Apple, and there's a variety of other tools. It's just a spreadsheet program. Now, all of those, Google Sheets, Excel, Numbers, have one thing in common. When you save data from them, you can save it as what's called a comma-separated value, or CSV file. In Google Sheets, you pick File, you go to Download, and you select comma-separated values, or .csv. If you wanted to produce something from this Google Sheet that looked exactly like the text file I just created, you would select tab-separated values. It puts tabs in between them rather than commas, but we've already covered that, so we're going to talk about comma-separated values. Comma-separated values are very, very common in a lot of data science and a lot of files. It's a common way of exchanging things, as I said. Excel can read these automatically. All Excel, Google Sheets, Numbers can read these things automatically and convert them with nothing to do, no work on your part, and they can all create them. So we will create this comma-separated values metal table.csv. Now, that just happens to store it in my downloads directory on my Mac. I'd have to move it over or worry about getting the right thing. So it just so happens that when I created that Google Sheet, I already saved that data, I saved that file as a CSV, and it's in the right directory. If you open the CSV, it looks like this. This is what a CSV file created by Excel or Google Sheets looks like. Each row is a separate line. There's a new line at the end of each, and it just has the individual values separated by commas. Now, it so happens that I finagled things because I'm going to be splitting, and splitting happens on white space, and white space includes blank spaces between words in a country name. I had to play around with this so that no country name has any blank spaces. So, for example, United States, I put United_States so that the blank space in between United and States didn't mess me up. Same thing with China. The People's Republic of China is now PR_China. Great Britain and Northern Ireland, which is their full name, it's called the United Kingdom of Great Britain and Northern Ireland. I just abbreviated that as GB because GB don't got no spaces in between it. And that just, did a little bit to fool it. Now, how do I read in a comma-separated value file? It turns out Python has some really cool tools that are already written that'll let you read in CSVs and exchange data with Google Sheets and with Excel trivially, but we're going to make you work toward that. We'll get to those. That'll be in Project 3, actually. You'll use those Python tools in Project 3, but you're going to learn how to write them yourself. because it's actually easy. If I want to read in this CSV file that Google Sheets created for me, it just works like this. I'll come down again and start a new one. Reading a CSV. I got 5 bits, should not be a problem. With open metal table.csv for read as comma file. I still have that header row. The first row, the first line, is still something I don't care about. I got to get rid of it. How do I get rid of a header line? I simply say comma file dot read line, and it helps if I spell read line correct. And now I simply throw away. I don't do anything with that line. I just read it in. I'm just checking my typos. Remember, test as you go. Check to make sure that you don't do anything. Now, I could have assigned this to, in the previous loop, I assigned this to header. I said header equals comma file dot read line. You can do that if you think you might need this data sometime. It's not a huge deal. In this case, I knew I wasn't going to need it. I'm just throwing it away. When we get to assignments where you're reading data from files and there are header lines, this is how you throw them away. You read them in and don't do anything with them. Now read rest of the file. Works the same way. Metals equal comma file dot read lines. You know what? I'm going to use read to show you that it can be done differently. Now, metals is a single string with all of there we go. Metals is now a single string with everything in it. So I have to split it on new lines. I told you before that splitting on new lines will break this up into the list that we want. So we'll say data equals metals dot split, and I want it split on the new line character. Okay. Okay. And now I have this list of strings. Okay, so as I said above, I used read lines. If I didn't want to use read lines, I just do a read and split on a new line. It has the same effect. It's cool. It works both ways. The point is, you now know how to do this either way. Now, what I'm going to do is I have to split each individual element in my one-dimensional list on the commas, because this is a comma-separated value, and so the commas are how we're going to split it. And so this is going to work just as above in the loop. I'm going to say, what did I call it up above? I call it data. I'm going to create a new 2D list, which I'm going to call it med list. I initialize it as a blank 2D list for I in range. It's not leave out range. It will cause me problems. Length of data. Med list dot append data sub I dot split on a comma. And when I do this, now we can see I have a 2D list from a comma separated value file. So the key to that was that I had a file which was created on Google Sheets or Excel or Apple Numbers or any similar program. I can take that data that is created on that commercial code, I can save it as a form that I can trivially read it in and process it with my Python skills that you folks can do right now. And in a couple of lectures, we'll get to the point where you'll be able to create data that Google Sheets or Excel will be able to input and read, import and read without any modification at all. So you'll now have a much better understanding of how to use these commercial tools and your coding skills to get work done. I'm going to stop there because it's 5:15 by my clock. Let me take a real quick swing through the slides. I think we covered everything. Not on the test, not on the course, but something you need to know. Anything in data science. When I got my data science master's degree a couple of years ago, 2 terms I learned very quickly and very early. Exploratory data analysis, or EDA. Okay. EDA, you know what that means? That means looking at the text file and seeing what's there. How did I know there was a header row, a header line on my table I had to get rid of? I looked at the data file and I saw what was there. And I said, aha, there's a header row I need to get rid of. Okay. That's doing EDA. That's doing exploratory data analysis. Exploratory data analysis is a fancy term that researchers who want advanced degrees and want publication and want grant funding use to say, to me, look at the data file and see what's there. That's all it means. The other thing you hear in data science and all these big data projects that people run is ETL, extract, transform, and load. Guess what? We just did ETL, extract, transform, and load. Extract means read in the data file. Transform means split that comma-separated value file into a 2-dimensional list that you can then use. Load just means put it in the variable you're going to use in your program. So big data science, all the data analytics that people have done and that we're going to do as part of Project 3 in this section. That's what makes this section different from the others, is we're going to do a lot of this data analytics stuff in Project 3. You're going to do EDA. That means you're going to look at the file and see what's there. Where are the header lines? What are strings? What need to be integers? What do I need to cast as floats? You're going to do ETL. ETL, extract, transform, and load. Extract, read in the data file. Transform, convert it from CSV or TSV or whatever other form it is into something you can use. Load, put it in a variable and let's process that sucker. That's it. Somebody comes around and says, yeah, I'm working at data science. I'm doing a lot of EDA. You go, you look at your data files. Somebody said, man, I spent weeks trying to do all the ETL. You tried to figure out the right code to write to convert a CSV file into the 2D list or the 3D list or whatever you want. So that's it. Okay. The first 2/3 of this lecture, you learned all about 2D lists, and you can now do problem 3, and you learned about rows and columns, and rows always come first. The rows are easy, and columns are a pain in the neck, but we just learned how to deal with them because we have the loops to do it for us. Okay. And then now that we have 2D lists, we learned a little bit more about reading them in from a file, extracting them, transforming them, putting them into a form we can use, into a 2D list or whatever, loading, let's get ready to program. Okay. That's what we've learned so far. Again, I'll put a message out on Blackboard, but Lab 7, the dictionaries lab, I will give you until next Wednesday to do that. But remember, you're going to start getting swamped with work, so please don't fall behind. Okay, it's okay with me. I mean, Kevin and Brian did a really great job, I thought, covering dictionaries yesterday, but it's okay with me if you wait until after the lecture. Until Monday's lecture, when we are going to cover dictionaries at long last. And then we'll get into another common kind of file called JSON, JavaScript Object Notation. Guess what? A JSON file, that's just a Python dictionary. It works great. With that, I will talk to you later. Have a good weekend.
Thank you, Professor. See you next week.
Thank you. See you next week. I'll be available. I have to duck to another meeting right now, but I'll be available later on. Email, Discord messages, whatever. Let me know if you got help. We'll take care of it.